My math lab? My math. Oh, 9.3, yes. Let's start with 9.3. Today is the 17th. In problem 92? On page? Oh, you said 9.2. I'll find it. 9.3, okay. Okay, 92 and 9.3. Let's take a look. Ninety-two. Oh, in 9.3. Okay. 92. Write x greater than 1 or x less than -1 as an equivalent inequality containing an absolute value. Okay, so since there is an or, whatever absolute value has to be greater than a number, right? Because, so here's 0, negative infinity, infinity, this is -1 and this is 1. X greater than 1 means this. X less than -1 means this. So what in absolute value is greater than what? And that will have these two as solution with a union. In other words, negative infinity, -1, union 1 to infinity. Which absolute value inequality will have this solution? And I'm going to put it in. It definitely has to have greater than, because it's an or. So what will you say? Can anyone suggest? Yes, indeed, the absolute value of x greater than 1. The absolute value of x greater than 1 translates into x greater than 1 or x less than -1. Very good. Thank you, Jackie. Anything else? Other questions? Anything else? Anything else you worked on? Yes? Jackie? Oh, 9 over the cube root of 3. We want to rationalize? Okay, very good. So of course I have to use the cube root. How many total do I need? How many total 3's should I have to eliminate the radical? So in other words, I'm asking the cube root of 3 to which power will be 3? Of course. If I don't have 3 here, I will never have 3 here. How many 3's do I have? How many more I need? 2. So it's 3 squared and 3 squared. So this is 9, the cube root of 9, 3 squared, over what? Exactly what I wanted. That's how I came up with the cube root of 3 squared, just to get 3 in the denominator. Yes, I can simplify now, and I will simplify by 3 because I can. So this is 3, the cube root of 9. You cannot simplify inside. Be very careful because this has power 1. And what is the power of 9 here? When I say the cube root of 9, what power do I mean? 1/3. Exactly 1/3. Thank you. Very good. Good. Next question. Becky? 51 on 9.4. 51 in 9.4. You said something? This one? (51 in 9.4). 51. 51. Where are you, 51? Yes, I got it. So y less than 3x minus 4 and y less than or equal to x plus 2. Perfect. Okay. So in this Problem we are asked to solve the system. What type of system is this? Of two what? Two linear inequalities. Excellent. Thank you, Mike. So, what is my first step? What do I have to do first? I have to write the equation. I did, the corresponding equation. Then I have to find 2 points to graph it because it's linear. When x is 0, how much is y? -4. Very good. So what is the ordered pair?
0.
Very good. So now when y is 0, just write 0 equals 3x minus 4. Move 4 to the other side, so 4 equals 3x, or x equals 4/3. Kind of hard to plot. So this one is 4/3, 0. It's 1 1/3. We'll figure it out in a minute. So now I have 2 points, 0, -4, and 1 1/3, which is here, and 0. Before I draw the line, I have to make sure that I know how to draw it. Will I draw it as a solid line or as a dashed line? It doesn't have the equal symbol, right? It is. Very good. Which means points on this line will not be part of the solution. I have to write the equation somewhere. I have y equals 3x minus 4. This is what I graphed. Since the line does not pass through the origin, I would like to use the origin. So the origin is 0, 0. Go back to the inequality. 0, 0. 0 less than -4. True or false? Since it's false, I cannot choose the interval or the region that has, yes, that has the origin, because if this one didn't work, no other point will. So I have to shade in the opposite. So let's shade in. All points here, everything here represent the inequality. Y less than 3x minus 4. All this red region. Okay, I repeat the process for y equals x plus 2. Y equals x plus 2. When x is 0, how much is y?
2.
Very good. X equals 0, y equals 2. 0, 2. Right here. When y is 0, how much is x? If this is 0, 2 plus what is 0? Very good. So -2, 0. So here it is. Can anyone tell us whether these two lines, whether they could be parallel? Who knows? Maybe I have, huge error in the unit here. But could these be parallel? No. What is the slope of the first line? What is the slope of the second line? Perfect. Will I draw it as a solid line or not? Good. So I'm going to draw it. I drew the equation y equals x plus 2. It does not pass through the origin. I'm going to use the origin. And the origin gives me 0 less than or equal to 2. True or false? Is 0 less than or equal to 2? Good. So then I will have to shade in and this is the region y less than or equal to x plus 2. What do I do now with the green and red? I have to find where both the region with ordered pairs that will verify both, right? I cannot use this, I cannot use this, I cannot use this because I only have green. So this is the region that has both colors. So not points on this line, points on this line, and everything else. Say it again. They overlap. Red and green overlap here. Or they intersect. Same thing. So this is both. Yes?
Since we just have pencils, how would we show that?
I have plenty for you.
Okay.
No worries. Good. Very good question. Anything else? Oh, I was just saying, where's my first page? Then I remember. Good. Next question. Anything else? Anything else? Becky, anything else? Why? Is it something, a problem that you worked on? Or is something else? Which one? You want to do another one? Okay, so let's choose another problem from 9. You said 3 or 4? 3. But I think you showed me 4. Are we talking about? I think you showed me 4. This is 9.4. So you want 9.4? Okay. So let's choose another problem from 9.4. Which part is not clear of the problem? Can you point out? Finding, graphing the equation? Finding points to, in order to graph the equation? Okay, so let's review just that for a second. So let's make up a linear equation. Any. Do you have a linear equation for me, or do you want me to make one up? Yes. So let's say x minus 6y equals 12. Is this a linear equation? Is it? Perfect. How many points I need to plot, to graph a linear equation? 2 points. Very good. Good. So I would like to determine the x-intercept. How do I find where this line is crossing the x-axis? How do I find where it's crossing here? No, I don't have to do anything here. Don't solve for any of the variables. So I would like to determine a point here, which is the x-intercept. How do I know how to find this? Or what do I know about all the points here? So can you give me an example of a point here? Just give me an ordered pair for this point, whatever you want. Very good. Let's say negative 6, 0. Okay, can you give me a point here? Just make it up. Excellent. Give me one more. Right here. Just make it up. Excellent. What do you notice? All these points have something in common. What do they have in common? Exactly. So in order to find the x-intercept, I have to set y equal to 0. So here's what happens. Look what I'm doing next. Since y is 0, I'm covering it. So how much is x when y is 0? So when y is 0, x is? Good. So what is the point that we just determined here? Right, but what is the point that we just determined? I need it in correct order. Yes, very good. So this is our x-intercept for this line. Now, can you make up a point here for me? Any point. Make it up. Excellent. Another one. Zero. Oh, of course. Daydreaming, sorry. Thank you, you're right. 0,9. So give me another ordered pair. Very good. And one more. So what do these points have in common then? Oh. We have to compromise a little bit. What do all these points have in common? Right. So now I'm saying this. How much is y? When x is 0 for this? Exactly. And what is the point? These are the points I need and nothing else. So now I'm ready to graph. I have 12, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 1, 11, 12, okay, and 2. These are my points, 12, 0, and 0, -2. And I draw the line by connecting them and extending. X minus 6y equals 12. Is this better? My pleasure. Okay, let's go back to 10.3 because we didn't get the chance to look at that. And then I'd like to look at the end of the chapter and review with the problems from the review. Okay, so simplifying radical expressions and the distance formula and the midpoint formula. So if you want to come back here for a second, this is what we did. Becky, just 1 second. See, we said when x is 0, we found y. And then we said when y is 0, and we found x. And the same thing here. When x is 0, we found y. When y is 0, we found x. Good. So we're on page 610. Let's simplify some more radicals. Let's start with 75, which is the 5th root of 64, x to the 10th, y to the 3rd, and the 5th root of 2, x cubed, y to -7. When I look at this radical expression, I realize the top and bottom, they have the same index. I also realize that they have common factors. So yes, I will rewrite the whole thing with the same radical because I can simplify. So I will write 64 x to the 10th, y to the 3rd over 2 x to the 3rd, y to -7. I will simplify as much as possible. And then I will try to simplify the radical expression. So what is left under the fifth root? There is a 64 and a 2, and that is 32. There is an x to the 10th and an x to the 3rd. That would be an x, copy the base, and what do I do with the exponents? Yes, so 10 minus 3 is 7. And then I copy y. So 3 minus negative 7. It's 3, 10. Very good. So I will say that I like 32 under the fifth root, and I like y to the 10th under the fifth root, but I don't like x to the 7th. Because x to the 7th requires work. So what do I do with this fifth root of x to the 7th? How do I present this? X to the 5th and x squared. Now, if you want to be super safe, then you will write the fifth root of 2 to the 5th times the fifth root of x to the 5th times the fifth root of x squared times the fifth root of y to the 10th. Of course, you can skip this step. If you're comfortable with it, you can skip it. So what will you write as the final answer? The only radical that will stay in the problem is this. Everything else will be free of radicals. So what do I write? Yes? Very good. Don't forget 10 divided by 5 is 2 times the fifth root of x squared. Is this fully simplified? Yes. It doesn't have radicals in the denominator. The index is bigger than the power, and no negative exponents in the final answer. Let's look at the distance formula and the midpoint. So would you like to choose? Or you can give us any two ordered pairs that you want to work with. It's up to you. Okay, I'm going to choose 96. The square root of 8, negative the square root of 12. Maybe we've done this one. So maybe we should do 95. Have we done this one? Okay, very good. Let's do this then. 3 the square root of 2 and 7 the square root of 3. They are asking us to find the midpoint. But let's find the midpoint as well as the distance. So let's find the midpoint first. Anyone remembers the formula for the midpoint? The average of x's and the average of y's. So the square root of 8 plus 3 the square root of 2 and negative the square root of 12 plus 7 the square root of 3. However, that's not good enough. I have to take it aside. I have to see if I can simplify this. I have to take it aside and see if I can simplify this. So let's try and simplify the square root of 8 plus 3 the square root of 2. Square root of 8 plus 3 the square root of 2. Can I further simplify 3 the square root of 2? No. But can I simplify the square root of 8? It's 2 to the 3rd, so I can, yes. So it's 4 and 2. So this is the square root of 4 times the square root of 2 plus 3 the square root of 2. But how much is the square root of 4? 2. So this is 2 the square root of 2 plus 3 the square root of 2. They are like radicals, 2 apples plus 3 apples, and the answer is 5 apples. So I have the x-coordinate of the midpoint. I have to write it again in a minute. 5 the square root of 2 over 2. Now we'll repeat with negative the square root of 12 plus 7 the square root of 3. Which of these two radicals has to be further simplified? This one into 4 and 3. So this is negative the square root of 4 times the square root of 3 plus 7 the square root of 3. But the square root of 4 is, so then negative 2 the square root of 3 plus 7 the square root of 3 will give us 5 the square root of 3. Now I can go back. I simplified both. And how do I write the coordinates of the midpoint? Five the square root of 2 over 2, and no one can simplify this. And the other one, 5 the square root of 3 divided by 2. And no one can further simplify this. Let's say we use the same points to determine the distance. What is the distance formula? The square root of x2 minus x1, yes, squared, don't forget plus, minus y1, everything squared. Good, perfect. So here is my x2, here's my x1, here's my y2, here's my y1. But I'm going to write these two fully simplified because I already did my work. So the square root of 8 is nothing else but 2 the square root of 2. So I will replace this by 2 the square root of 2. And I will replace this by negative 2 the square root of 3. Or not, depends. But if I do that, I will be able to simplify and then square. So I recommend it, because otherwise it will be way more difficult. So d equals the square root of x2, 3 the square root of 2, minus x1, 2 the square root of 2, everything squared, plus y2, 7 the square root of 3, minus negative 2 the square root of 3 will be plus 2 the square root of 3, everything squared. So how much is 3 the square root of 2 minus 2 the square root of 2? The square root of 2. How much is the square root of 2 squared? Exactly, plus. How much is 7 the square root of 3 plus 2 the square root of 3? Right, let's write that and not do it in our heads because I won't like you to see it. We can, but it's better if we do this. So then I have 2 plus. Remember, this is a product. I have to square product. This is not a binomial squared. Do not confuse the two. I have to square 9 and I have to square the square root of 3. When I square 9, I get 81. And when I square the square root of 3, I get 3. So then final, I have 2 plus 243, or d equals the square root of 245. If I want a simplified form of this, then I would have to look inside 245. I have no idea what it is, but I know that 245 is divisible by 5, and I have 49, right? So then d equals the square root of 5 times the square root of 49. So the exact answer will be 7 the square root of 5. Now if you want an approximation, you will punch in the calculator the square root of 245. And if you do that, what do you get? What is the square root of 245? I got 15.65 approximately. And it's done. Was it? Yes. Okay. Very good. So let's see what else is in this section. Not much else. Let's also we've done that already, but let's simplify also 49 on the same page. And 49, the fifth root of negative 32 x to the 10th y what is the answer? And we can go back to 10.2. What is the answer here? It's the fifth root. The answer can be negative. So which number I raise to the fifth power to get negative 32? We know that. Negative 2. The fifth root of x to the 10th is x to the second power. And this is the fifth root of y. And that's it. So I'm back to page 602. 601, 602 to review section 10.3. Okay. Yes, Becky, go ahead.
What was the midpoint formula again?
The average of x's, comma, the average of y's. So x1 plus x2 over 2, y1 plus y2 over 2. Okay, so let's choose, for example, 78 on page 602. The eighth root of 4y squared. And now because you know the entire chapter, you can say, how can I simplify this? And the answer is not much, but we can still do something. So this is the eighth root of 2 squared times y squared, which is the same with the eighth root of 2 squared times the eighth root of y squared, which is the same with 2 raised to which power times y raised to which power. 2 raised to, say it again, 2 over 8, which is 1/4, and y raised to 2 over 8, which is 1/4. So now I can go back and say that this is the what root of 2y. So yes, although we could not simplify much, we reduced it from index 8 to index 4, which is in fact an accomplishment. Okay, let's look at 57. Y to the third times z to 1/6 over y to negative 1/2 times z to 1/3. This looks awful, right? Not a big deal. What would you do first? Let's talk about it for a minute. What will you do here?
Where did Z by?
Say it again.
Why?
There is no square here. No. So what we need to do first is raise this to 1/6 and then raise this to 1/6 because I want to eliminate parentheses first. That's my target. So y to which power? What happens to 3 and 1/6? What operation I perform with 3 and 1/6? Yes. So how much is 3 over 1 times 1 over 6? Very good. Excellent. Multiplied by z to which power? It's power 1 and power 1/6. So what will the power be here? Very good. Over y to -1/2 times z to 1/3. Okay, now you tell me what would you do next? Any suggestions?
cancel y.
I cannot. Careful, they have powers. What I can do is copy y and then decide what to do with the exponents, and then multiply by z, copy z, and decide what to do with these exponents. So what happens to these two exponents? Yes, from the exponent of the top, I subtract the exponent of the bottom. So from 1/2 minus -1/2, what do I get? 1, right? So 1/2 minus -1/2, I have to distribute, and I get 1/2 plus 1/2, and the answer is 1. That's why this is 1. Good. Now what do I do with 1/6 and 1/3? Well, I have no choice. I have to write them because those will not go away. I have to find what next? Here's your hint, which is, good. What is the adjustment for this one? Because 6 is 6, but here I have 3. So I have to change this fraction into 2/6. Very good. So then the numerator is 1 minus 2. But how much is 1 minus 2? Right, that's trouble. So y is y, but z is to -1/6. Okay. Now, since we finished this chapter, I know I cannot leave negative exponents in the final answer. So how do I proceed? So y over z to which power? Anyone? Mike? Help? Anyone?
1/6.
Very good. Is that clear? Let me remind you. A to -n is 1 over a to the nth power. Good. But what does this mean in the denominator? Anything that has a fractional exponent is coming from what? Right. Which radical?
So 6.
Of z. Okay, now it's another type of trouble. I need to rationalize. Which radical will rationalize? Which index first? Of course, it has to be the same index. How many z's am I missing? 5 of them. So now the top is clear, is y times the 6th root of z to the 5th, and the bottom is clear, because I had the 6th root of z, and I needed the 6th root of z to the 5th in order to get what?
Z.
Exactly. Do not be tempted to simplify this z with this z. That will be terrible. You can't do that. Okay, so let's find one more, and then go back to 10.1. Okay. Yes, let's say 49 on page 601. Okay. I just want to finish reviewing, and then I will choose problems for you to work on. Okay, so 4u squared raised to 3 over 2. So we are asked to simplify this. Be careful, because these are two factors. 4 is a factor. U squared is a factor. I recommend changing 4 into, what could I recommend you to change 4 into? That's it. There is nothing else. And we have to raise both factors to 3/2. So when I copy the base and multiply 2 over 1 by 3 over 2, what do I get? Right, which is, I'd rather simplify first, but that's fine. 3 times u to which power? That's it. So I will write 8u cubed. Okay, finally 10.1. Starting from page 593. Assuming variables are all real numbers, I would like you to simplify this. Variables or x, any real number. And also I would like to simplify this. So for these two examples, x can be any real number. What is the answer for the first one? Okay, what is it? 10.1. Last one we need to review before we look at the review in the book at the end of the chapter. How do I simplify this, knowing that x can be any real number? Perfect. How do I factor it? Very good. And then the answer is? Perfect. Excellent. Okay. What about the cube root of x plus 2 squared? What is the answer for that? The index is odd. Those are friendly to us. X plus 2. Because the index is odd. Very good. That's pretty much it. So now let's go to the end of the chapter. There is a chapter test on page 647. And there is a review that starts on page 645. I highly recommend, I really like this part of the book very much, in which at the end of each chapter, it has what it's called highlights. Definition and concepts from 10.1 right here, and an example or two here. Then section 10.2, what we learned in section 10.2 with an example here. I really like this part. 10.3, the concepts, what we studied, and with example. Really nice. I really like this part. I will miss this book for this particular reason. We're not going to be using it again, starting from fall of next year. So we have this, spring, and summer, and then we toss it. I may make copies of that section and give it to my students. I really like that part. So you would like to review again, or just have a summary and look at the chapter test? Yes, any particular section from chapter 10 that you would like to review? Okay, well, this is also part of the review. Yeah, so let's take a look. Let's say rationalize the denominator. I'm looking at problem 12 on 647. So 4 minus the square root of x over 4 plus 2 the square root of x. So let's rationalize the denominator on this. Let's take 30 seconds and rationalize the denominator. Can anyone get us started for everyone to see, or do we have an idea of how to rationalize the denominator? I'm hoping you're going to finish my Labs Plus between now and Thursday, so you don't have any gaps. Okay, please. Or homework, something, anything. Okay. So do we know how to proceed, anyone? The conjugate, yes. So we're rationalizing the denominator, so we have to multiply top and bottom by. Very good. Good. Perfect. That's what we need. Please use the special product that we have an agreement on. Please. So what do I have to write? The first term squared is? Yes, don't forget it's minus. It's a difference of squares. Now careful when you square this, because you have to square each factor. So minus what? 4. The square root of x squared. That's it. Now the numerator has to be distributed. 4 distributed to 4. 4 distributed to negative 2 the square of x. The square of x, very good. Now negative the square of x times 4, or 4 times negative 1 times the square of x. That's better to think in terms of 4 times negative 1 times the square of x. 4. Very good. And now finally, this is negative and negative, so it's going to be positive. 2 is outside, and the square of x times the square of x is? That's it. Perfect. So now the numerator becomes 16 minus, since these two are like radicals, I will write negative apples minus 4 apples is negative 12 apples plus 2x over 16 minus 4x. It would be terrible if you would try to simplify terms. What we can do, we can simplify it a little bit, because I see the numerator has a common factor and the denominator has a common factor. What is the common factor at the top? I have 3 terms. I have 16, negative 12 blah, plus 2x. So these 3 terms have a common factor. I want to put it in front. 2 indeed. Now these 2 terms have a common factor. I want to put it in front. Very good. So what is left at the top? Careful, because I have 3 terms, I have to write 3 terms. Because I started with 2 terms, I have to write 2 terms. I'm ready when you are. Two times what is 16? Good. Minus. 2 times what is 12? 2 times what is 2x? Perfect. And the denominator? Perfect. Now I can simplify. And I can only simplify 2. So 2 divided by 2 is 1, 4 divided by 2 is 2, and I will leave it as is. 8 minus 6 the square of x plus x over 2, 4 minus x. We do not multiply the factors in the denominator. We will see this when we get to chapter 7. Very good. Are we comfortable with rationalizing? One more. Very good. So let's find another rationalizing. Let's say 110 on page 646. And let's choose to rationalize the other one, not the denominator but the numerator. So let's suppose the problem is asking us to rationalize the numerator.